So we are starting the another type of the function, which is very important, and a lot of curves and graphing is all about this. So we are just going to start this one. So I'm sure that my screen is visible to you. Can you see
Yeah.
this screen? Okay.
Yes.
Well,
Yes.
let's see. Very briefly, we'll go through these slides. So please read if you can.
All right. Inverse function.
Inverse function. So this is our topic. We will talk about that. We will solve some question. We will see the step-by-step procedure to find the inverse, and then we will talk about some characteristics of inverse functions. Now let's see. So please read this one.
All right. Uh, Today's outline. Uh, is that an oh no inverse function?
So keep on reading.
History behind function. Finding inverse of a function.
So this is the most important, finding inverse of a function.
Application.
The application of the inverse function. Now let's see. What is a function?
All right. Uh, are you asking me? Oh,
Yes, if you can.
or is that what you're reading over there? Function is y equals fx.
Yes. So this is written over here there. Let's see, this is the part of their definition. We are just coming out with this one. Please, read this one.
Sure. A function is a mathematical process that uniquely relates the value of one variable to the value of one or more other variables.
Yes. See, this is the function that is y is equal to fx, and here input variable x and output variable y. So y is the output variable and input variables are x. Now let's see, next is example. So look at this. So as in the previous slide, we were looking that there are actually what we can say the two sets. One is of x, so it is containing a, b, c, and there is a function. There is the relation between the other set y, which contains 1, 2, 3, and 4. So for each a, there is the image, and also for b, this is going to 4, and for c, this is going to 2. Although this is not included, it's not image of anyone, but here we can say that each and every element of x being projected to the element of y. That's why we can say that f is a function from x to y.
Okay.
So now let's see what is next. So the next is that is historical background. So it's we are
Okay.
not going in detail, but it's just a glimpses of the historical background of the inverse functions. So very briefly, uh, please read this one.
Sure. Galileo gave the statements of dependency of one another.
Galileo gave the statements of dependency of one another. So one and another, that was the Galileo. So lot of misconceptions about this scientist. So he was hanged to the Pisa Tower, the leaning tower of the world, and he was the first to give the idea that the Earth is revolving around the sun. So any
Okay.
at that time, this was one of his assumption that if you are relating two things, so one must be depending upon the other.
Right.
In 1673, Leibniz used to use the word functions. So he was a German mathematician. First time
Okay.
when he was talking about the relations of the things mathematically. So at that time, he was using the term function in 1673. Then the next one is in 1734, the notation fx was introduced by Euler. So this is the latest notation. We are still using that f of x, the function of x that was used or introduced by Euler. So these are the
Right.
three prominent mathematicians who have contributed in the field of function. Anyhow, we are not going in detail for the history, but we are just looking the glimpses of the historical background. Anyhow, if you can read this,
Okay. What is inverse function?
so it's a definition. Now we will have to pinpoint the definition for the easy understanding. So look at this. Please read this one.
Okay. Let f be a function with the domain D and range E. The inverse of f is the function f minus 1 defined by f minus 1 b of b equals a, where a is chosen so that f of a is equal to b.
So for easy understanding, you can say let f be a function with domain D. Domain is the set of the what we can say the elements from where the images are being what we can say plotted. And the range E, that is the second set. The inverse of f is the function f of inverse, f inverse. So we can read this f inverse defined by f inverse of b is equal to a. F inverse of b is equal to a, where a is chosen so that f of a is equal to b. So from here you can say that initially it was f, the value of the function at a is equal to b. But if we are getting the inverse of this, so we will have to reverse each and everything in the sense that this f will go on the other side over here. This will become f inverse of b. That is equal to a. So the reversal of each and everything. What I mean to say, this was originally this was f of a is equal to b, or the value of function at a point is equal to b. Or in other words, we can say that a is projected to b. But if we are looking for the inverse, so what we'll have to do that f inverse of b, f inverse of
Right.
b is equal to a. So it's coming in the reverse direction that now b is going to a as a was projecting to b. So this is the basic what we can say let f be a function with domain d, that is the first set, and the range E, the inverse of f is the function f inverse defined in this way. Now let's see.
Okay.
So we can say that f of inverse of the function is equal to x. So, and the function
Okay.
of the inverse function is equal to x. So in this way, what we can say that actually x is the value, and if we are taking the inverse of a function, that will be that projected value at that point where the x is. And similarly, if we are taking a function of the inverse function, once again, we are reaching at the same point. Now let's see what functions are invertible. So here the question mark is that when there are so many functions, so how can we find their inverses? So we will have to make a thumb rule that these type of the functions, they have what we can say inverses, and these are the functions which don't have inverses. So that's why we will have to first, whenever the function is given, so we will have to decide whether it has an inverse or not. So we
Right.
will have to focus on this. If it is characterized as a function which don't have any inverse, so we let it go. We should say the inverse does not exist. But if it is categorized in that category, if it has some characteristics which are just necessary to have the inverse, then we will have to go further. We will have to do some manipulation to find its inverse. So it's a basic thing that what functions are invertible. So we'll have to get the answer of this big question. That is, please read this one.
Okay. In order for f inverse to be a function, there must be uh, only one a and d responding to each b and e.
Yes.
Such functions. Oh,
Okay,
sorry.
okay. Just hold on. Let me explain this point.
Sure.
This is a very important basic one. Then in order for f inverse to be a function, there must be only one A in D corresponding to each B and E. So it's a clearly saying that they must have one-to-one imaging. There must not be any duplication. So arrow is coming from one element and going to only one. So in this way, if we are reversing the direction of the arrow, there must be one and only one. So in this way, in D, that is the domain corresponding to each B in E, that is the range, or what we can say the codomain. So range is also called codomain. So in this way, only one arrowing, one imaging going one to one. So that means that function must have the inverse. The second thing is, please read this one.
Okay. Such functions are called one-to-one.
One to one. So it's a one to one. One image is one arrow is going to only one. So that's why if we are looking for the inverse of function, so that function must be one to one. Next is this one. Please read.
The graph of such functions passes horizontal lines test.
Okay, so this is another characteristic. So if we are looking for a function, if the graph is given and we are asked to find its inverse, so first we should test it, the horizontal line test, and I'm sure that we have talked about that. So what is the horizontal line test of a
It's
function?
So it's pretty much what it is you draw like two lines and then or like as many lines as you want going a certain direction. I think if it's a horizontal line test, you just draw horizontal lines. But if two parts of the graph or like two parts of the function meet on the same line, then it's not one to one.
Okay, okay. This is a great explanation. Anyhow, the simple words you can say the horizontal or the vertical line test is if the graph is given and if you are just moving the line horizontally or vertically, if it touches at the one point at a time, then it will be a function. If it is touching the 2 point, then it will not be a function. Are you getting this?
Yeah.
What I am saying that if there is a graph and you are just moving the line horizontally or vertically, if it is touching only one point at a time, then it will be a function. If it is touching 2 points at a time, it will not be a function. The simple example is if you have a straight line and if you are moving a vertical line, so for every instant, it will touch only one point. But if you have a circle and if you are moving the vertical line, so every time it will touch 2 points. Am I right? Are you getting this?
Right.
So that's why
Yeah.
it's a nav function, not a function. Now the last one is if f is continuous, then f inverse is continuous too. So continuous function we'll talk about in detail in the near future. So that's why I'm not talking about the continuous function. Anyhow, Let's see. So look at this one-to-one function. So one-to-one, as we are talking about one-to-one. So for the existence of inverse of any function, that function must be one to one. Now let's see.
Right.
Please read this one.
Okay. One-to-one functions, every element of the range corresponds to the exactly one element of the domain.
Yes, so it's a very simple and straightforward definition that every element of the range corresponds to exactly one element of the domain. So range and domain must be the same. So that type of function is called one-to-one. Look at this. So here we can see that we have the two ovals, blue, this on the left and on the right, the blue ovals, two ovals. This is are containing all these A, B, C, Ds. And here on the right, in the right oval, 1, 2, 3, 4. All these Roman
Right.
alpha counting numbers, notations. So the arrows are going from here to there, left to right, left to right. So that's why it's a domain, the set of all these elements that is called domain, and the set of all these is range because it's coming from here to there. There is now it's a one-to-one function because the domain is equal to the range. What I mean to say, the number of elements in the domain is 4, as well as the number of elements in the range is also 4. So it's also called codomain. Range is called codomain. So domain and the codomain are range and domain both are the same. So that's why it must have the inverse because when we are reversing, so this will go on this and this second will go to B, third will go to C, and the fourth and the last one will go in this way to D. So that's why that must be one-to-one functions to have their inverse. Now let's see.
Okay.
Please read this one.
All right. Why all the functions don't have inverse?
Oh yes, why all functions don't have inverse. So it's a very crystal clear that if we are asked to find the inverses of the functions, so we will have to be crystal clear that what type of functions have their inverses and what don't have. So that's why this question is very necessary to ask. All functions are not one-to-one function. The only reason is that all functions are not one-to-one. If they are not one-to-one, so there is no question of their existence of inverses. Next is why all functions don't have inverse. So one more reason is just to explain this one. So once again,
Okay.
we have the two sets, the left oval containing ABCD, and on the right, the numerals 1, 2, 3, 4. So here the arrows are going in this way. So 1 to 1, 1 to 1. Now look at this. This is just the something different. Now D is approaching to 3 also, and 4 is all alone. So nothing for the 4. So 4 is not being the image of any element in the first set, that is a domain. And here we can say that this is a range, but domain and range, they are not equal because domain consists 4 elements and range or codomain is consisting of only these 3 elements. I'm sure that you are with me, but I'm saying
Yep.
you are getting it. So
Yeah.
it's very simple. So 4 is not included in the range. So domain and the range, these are not equal to each other. So that's why, but we can say why all functions are not have, we are looking for that. Now look at this, the two functions. And now look at this. So once again, the situation is just like that, that this is not a function, and there is no question why it is not a function. Have you any sweet reason?
Because a function can't be two things. Like if an input can't have two different outputs in the same function.
Okay, one more easy way is, let's suppose if you are considering this at first, this is the these are the women and these are the men, and you know that the woman can marry to only one man at a time. So look at this. This number three woman is going to, what I mean to say, this and this. But I think it's a fair case that two men can have the, what we can say, this cannot be possible that two men have the relation with the one woman. So that's why. And one more thing is this four. This four is all alone, having nothing, any relation to anyone. So that's why it is basically not a function. Am I right? Are you getting this?
Yeah.
So it's an adder function because the tree has two images at the same time, C to D, and it's not possible. And one more thing is that this 4 has nothing to do with all any one of these. So basically, it is not a function. If it is not a function, so there is no question of inverse. So in the last, we have seen that the range was not equal, if we can recall that one. So that was this due to, although this is a function, but it is not there is no existence of this. The reason is this, because the range and the domain, these are different. And here what we have seen, that basically this is not a function. So no longer a function. So no question of inverse. Steps for finding inverse. Now we will do some practical steps, that how can we find the inverse of a function. And in the next lesson, so I will come out with a full exercise step by step to find the inverse of the given function. We will do a lot of practice. I will show you all those slides, all those questions I will solve in front of you to find the practically the inverses of the given functions. But here we are just outlining the method. So this time we are not exercising, we are just putting the outlines, that we are just
Yeah.
getting the steps. We are just making the working rules, that how we can get the inverse of a function step by step. So that's why the one more part, and in the next lesson, we will talk about the real exercising, how to get the functions graphically and algebraically. If the graph of the function is given, then we'll find the graph of the inverse function of that. And also algebraically, if the function is given, we will find its inverse. So here we are just outlining the steps only. So be ready for that for the next lesson. Anyhow, so these are the steps. So replacing with F inverse. This is the first step. Solve for Y. Then we will solve for Y, and I will do for that in the exercise in the next lesson. Switch X and Y. So we'll have to change this. Stick Y for Fx. So these are the 4 steps. And we will do all these 4 steps in detail practically. But for the steps, or for the outlining, or for the working rules, so these are basically 4 necessary steps to reach at, what we can say, to the inverse of any function. But
Okay.
anyhow, you can go from the bottom to the top, or from the top to the bottom. So if you are starting from here, so you will have to do all these and you will reach over there. Anyhow. Look at this. Now it's we are just uh, this sample problem is over here. Look at this. If you can see solution. Let's see. This is the function given. Fx is equal to fx. Are you looking my screen?
Yes.
Okay. The given function is that 5x plus 3 divided by 4. So find inverse of this. So look at this, how we are finding the inverse algebraically. So fx is this one. So what we are doing, that y, fx is being replaced with this y. On the right hand side, the things are same. So when we are doing this, so we'll reach on the next step, y is equal to, we are actually replacing the as per those steps. You can recall those steps. I will send you all these slides and you can rematch, you can look back to those steps. So it's a y. That was the first, that we are replacing fx with y. That is fx
Okay.
plus 3 is 4. This is actually the first step. Now x, once again, the interchanging of x and y. So y is coming over here, x is over here. And in this way, what we are doing, so we are cross multiplying. So this will become 4x on the left, and this will be remain as it is, 5y plus 3. So from here, 4x and this 3 is coming over here on the left hand side. So this will become negative. So 4x minus 3 is equal to 5y on the right as it is. So from here, what we are going to find the value of y, and dividing the whole both sides with 5, we will get y all alone. That is on the left hand side. On this side, this
Right.
over here, and this is as it is, and this 5 is dividing the right hand side coming from here. So f of inverse. So y was f inverse x. We are replacing y with f inverse of x. So this will become 4x minus 3 over 5. Look at this. This was fx actually. This, isn't it?
Yeah.
And inverse is 4x minus 3 over 5. Look at this. This is 5x. This is 4x. This is positive sign. And we have negative 3. 3 is a constant. Nothing doing with that one. Here, denominator was 4. And we have 5 now. So these are the practical steps. So if I'm just going back to for your eyes only, look at this. So this was the given function. Once again, just look at that. The
Okay.
fx is given in this way. So we are looking for the inverse of this function, this function. So we are just starting from the given function fx. So fx plus 3, 4 as it is. The first step, what we are doing, that we are replacing this fx with y. So y is over here. So I'm sure that all these steps are clear. Is there any
Yeah.
confusion? You can ask.
No, I think I get it. Yeah, it's pretty. I
Okay.
get it. I get it.
Yes, yes. So we are just moving to the next. When we are moving to the next, so we are getting this, that y we were there in the last step, in the last slide. So y is equal to fx 5x plus 3. So here we have the algebraic expression equation. So we will have to manipulate something to get the value of x, because here we have y. So look at this, what we are doing. So we are just replacing, we are just getting the x, y. So this will become replacing. So y is replaced by x on the left hand side. And here that was x is replaced by y. So rest of things are same. So very critical step. key to the solution step, very important, that here when we are putting the fx is equal to y, now we are replacing each and every interchanging the y with x and the x with y. So interchanging of x and y. So y will become x and this x will become y, and this is the step where we have x on the left hand side. Now next is what we are cross multiplying. So this 4 will go on this side, that 4x are multiplying the whole equation with 4. So on the left we will get 4x, and on the right this will go with that, and we have 5y plus 3. So this is all about the 4x. So we are just getting y all alone. To get this, subtracting or adding -1 to -3 to each side. On the left, as this was, and on the right, subtracting -3 will diminish this. So we will get 5y. But we are looking for the y. So we will have to divide this equation both sides with 5. So division of 5 will give this step. So y will be 4x minus 3 over 5. So y was actually the f inverse of x at the time of beginning. So we have just replacing y is equal to, because fx is equal to y, then y is equal to f inverse of this is this. So this will become our answer. Is there any question? Anything?
No, I'm getting it. Yeah.
Yes, yes, you are with me. Thank you. Anyhow, so once again, look at this. So this is the actual summary where what the steps are over here. So inverse function summary is to find an inverse function, either step one, let, as we were doing in the previous slide, let y is equal to the function, whatsoever the function is. So whatsoever the function is given, just put it equal to y, as we have done in the previous question. So step two, rearrange to find x. That was all the rearrangement. Then step three, swap x and y. That's why I was saying that swapping x and y, interchanging actually. So,
Right.
or write the given function as a flow chart. Reverse all the steps of the flow chart. So I'm sure you know the flow chart. That is also called the mind mapping in computer programming.
Right.
So anyhow, that was the chart. We are not talking about the flow chart at this time, but that can be reversed in that way. So the next one is that is the application of the inverse function. So let f be the function that converts temperature in degrees Celsius to a temperature in Fahrenheit. So that is the very common application when we are reversing. So degrees Fahrenheit. So let f be the function
Right.
that converts temperature in degrees Celsius to temperature in degree Fahrenheit. So a lot of conversion is being done. We have the softwares to convert any quantity into the other units. So that all is being done with the help of the inverses of those equations. So look at this. This is the Fahrenheit. Let's suppose the function is of the Celsius, degree Celsius, and 9 by 5 multiplied by C, the Celsius plus 32. So that is all
Okay.
about the conversion of the Celsius degree to the Fahrenheit degree.
Okay.
Look at this. And if you are just converting this one, so what you will have to do, just get the f of inverse. Inverse, if f Fahrenheit degree is related to this way, so the Celsius degree can be converted just to find the inverse of this function. So inverse mean what I mean to say, look at this. So this is 5 over 9 instead of 9 over 5. The same sign of multiplication is coming over here. And here what you are doing, That is, you are adding 32 to Celsius degree. So this time you are
Right.
subtracting 32 to Fahrenheit degree. So this is the practical example of the what we can say inverse function. Because if you have this function, Fahrenheit function is the function of Celsius degree, and that can be written in the mathematical form. This is the equation. So whatsoever the Celsius degree, just put the value of that, you will get converted to Fahrenheit degree. But if you are looking for that, so you will have to get the F inverse of the Fahrenheit. So inverses will be done on this way. And you can
Right.
also do at your end. So any query? This is for you.
I'm thinking. I don't really. I don't know. I don't think I have any questions right now. Maybe if it
Okay,
pops up
okay,
later, I
okay.
could ask you.
Okay, okay. I will send you the set of some questions when you will solve all those. So you will come to know that what is to be asked. Anyhow, you can ask anytime. So you're most welcome. Your queries, your questions. So you can ask anytime. Anyhow, so what we should say at the end.
All right. Thank you.
So thank you. Thank you very much for today. So that is all about that. So just to say Allah Hafiz.
All right. Love this.